prepare for your examination. So can I start the share my screen?
Yes po, Miss.
So let's I'll
To our
start with a lesson. I'll share my screen first. Okay, thank you.
Thank you, Miss.
Wait, Okay. Okay, so our topic is a influence line for statically determinate structures. So for we just discussed first what are the loading that is involved for determining the influence line for statically determinate structures. So we have a dead load. So the dead load is a uniformly distributed load.
Excuse me, Miss po.
Yes.
Wala po kaming nakikita po sa Teams. Wala pong naka-display.
Wala, baka wala naka-display. Baka ano pa, start.
Ay, okay na po.
Nag-share na.
Ayan, Miss.
Okay na, okay. Okay, thanks. Okay, so our load is a uniformly distributed load Q that does not move stationary. So it's a stationary load. It is called dead load or fixed load. Moment diagram display the variation of respective quantities along the beam. So the variable x indicate the location of the section. So this the dead section you can choose anywhere. You can cut here or in here. So the variable is the location of your the location of the point where we want to take the maximum moment or shear force. Then for the live load, so if a structure is subjected to a live load or moving load, for example, this beam AB, and you have a point load of 1, and then the location is variable x. So it can be anywhere. It can be here. Your x can be. Okay. Your live load can be here or here, depending on so the variation of the shear and bending moment it can be described using the influence line. So the influence line represents the variation of either the reaction, shear, bending moment, or deflection at a specific point in a member as a unit load moves over the structure. So what are these structures? So sometimes you will have a crane. So when you want to analyze a crane like this one, the first row, this crane. So the load is moving, right? You see, you have a moving door and MRT. So or even the bridge, right? With bridge design, you will have a moving load. So the question is, so variable x indicate the location of the dimensionless unit load. So the question is where the moving load should be placed on the structure so that it creates the largest moment at the center of the span. So you want to know, because if your load is moving, you will have a variable moment. So you will want to know where would be your where should you put the load so that you will have a maximum moment or maximum reaction or maximum moment and maximum shear. So later on, we will find out where should we put the load. So to draw the influence line, we have two procedures. Actually, there's three. Later on, I will teach you another method you choose which one. So your answer, you can check it yourself. First, you do the tabulate the value. So we place the unit load at various location along the structure. Okay. At each location, use statics to determine the value of the function, reaction, shear, or moment at the interest. And also determine structure have that consists of straight line segment. It is sufficient to locate the unit load even only at the, if you put the load at the endpoints of each line segment. Then is to the influence line equation. So we place the unit load at the variable position X and then compute the value of R reaction, V the shear or moment at the point of interest as function of X. So to be able to understand this procedure, we go through let's see example. Let's solve an example. Okay, okay. Wait, sorry. Before we go to an example, we have we assign first, we follow the this sign convention. So if because we have to cut the beam into segments to be able to calculate the moment, the shear, and the reaction. So for segment on your shear will be downward, normal force will be to the right, and then positive moment counterclockwise. And then on the right side will be the counter of your left. So if your shear is downward, here is upward, and then your normal force is going to the left and moment clockwise. Okay, so it's the same here. Okay, now so let's go through an example to construct the influence line for the vertical reaction at A. Okay, so we have to, as I mentioned, right, you have to put the what the moving load at certain points here. We draw. So you have to be able to draw these. You have to tabulate. But I already put. Okay, wait. We first solve. We first solve the load at if it's at 0. I'll draw the. Why it moves. Okay. Depend. So is here. Why I'm not. Okay, your load is here first. Okay. So use a unit load 1 and then calculate. So summation moment, counterclockwise positive. So summation moment equals to 0. You take the moment at B. So your forces will be AY times 10. 10 is the let. And then if it's if the load is at 0 at reaction A, so this 1 times instead of 7.5, it should be 10. Here. 10. So if it's okay, so if it's 10, if you resolve it, AY will be at for this segment first. AY times 10 plus 10. So it will be AY equals to 10 over 10, right? So it will be 1. Okay, so that's why we have 1 here. This one. Let's see. Erase. And take the laser. There. 0. If you put the point, the load at 0, your AY will be 1. Okay, so then let's solve for segment. If your load is at 2.5, so this one. So if your load is at 2.5, so here we already solve it. AY, take moment at B. So AY times 10 plus 1 times 7.5. So is a 10 minus 2.5. That's why we get 7.5 equals to 0. So if you resolve it, AY will be 7.5. So that's 7.5. Laser point. So if it's at 2.5, your AY will be 7.5. Then if you put it at from the support, 5 meters from the support, so you resolve it, take moment at B. So summation moment at B equals to 0, negative. Counterclockwise is positive. So AY is going clockwise. So negative AY times 10. 10 is the length of the beam plus 1, your load times this distance from B. So AY will be 0.5. That's why we have it here. So if you do another calculation, you just change 5 to 7.5. Your AY will be 2.5. So if you then put the load again at here, at 10. So means it's here. Okay. So if you take the moment at B, it will be AY times 10 equals to, because there's no variable, so it will be 0. So if your load is at 10, your AY will be 0. So if you plot all these points, here, then you will get where you will get this is the influence line. So this is the influence line of reaction A. Okay. So if at 0, here is 1, and then 2.5, or you just plot 10, go straight away. You can plot easier because it's a straight line. So you actually just need 2 points, right? You only need this point and then this point, and then plot the graph. So at 0 you have 1, and then at the what do you call it, here at the end at 10 you have a 0. So then you can draw it. So actually you can see that you only need to place the, so it is sufficient just to locate this node, like, nodes. This is sufficient to locate the unit load at the end points of A and B. So actually we don't need to do all these so many points, but at least you know how do we arrive at these, because if it's a simple beam like this, you know already that it's simply supported. So you just need 2 points to be able to draw the influence line at reaction AY. So another way to solve this equation, we use the influence line equation. Okay, anyway, let's go to the next page. Okay, so influence line equation. We've just now, what was the, let's go back to the procedure. This here. Place the unit load at a variable position X, then compute the value of, so now we're only looking for our value of our reaction. So we place it at the unit load at the R, okay, and then at the point of, and then calculate the value of R at the point of interest as a function of X. So we want to know the value of R or AY. Okay, so let's go back here. So we put it at the distance X. So here is X, and then change it to okay. Right, place your pointer. So X and then 1. And then take the moment at B. So we didn't put the okay. Counterclockwise positive and counterclockwise positive. That's why we have negative AY times 10 plus, okay, so the distance of the point load from reaction from B is 10 minus X, right, times 1. So your influence line equation will be this. So AY plus 1 minus 10 of 1 over 10X. Okay. Actually, it's 1 minus X over 10 to, right? To simplify. Simplify. So you can put it here like this. So that your this equation, this line, the equation is, so means that if you have any value of X, you put it here, your AY will be, if you put this load at any value, your this will be the equation for your AY. So let's go back to the previous example, the one that we checked, to check if our equation is correct. Okay. Okay, so check if this equation is correct. We apply, we put in 0. If this is 0, then AY will be 1, correct? Okay, so if X is 2.5, 1 minus 2, 2.5 over 10 will be 0.75. And then if it's X is 5, so 1 minus 0.5 and so on. So that is our first example. Do you have any questions? Since some are live, you have any question? Any in the chat you can put it. Okay, never mind. I'll proceed. If you have no question, let's see. Did I see? Let me check the chat group if you have. Okay, there's no chat. Okay, so you just, if you have any question, you just put it in the chat. So we proceed with the equation 2. Okay, equation 2. We are asked to construct the influence line for the shear. Now it's a shear. Influence line for shear at point C. I didn't tabulate. Okay, let's this is difficult. We just first solve the influence line equation. Okay, so where's the it's here 4 and let me check. Take the picture. You can draw it. Sorry. Okay. It's 4. Okay, let's draw the, because we didn't have it in the other side. Okay. So we draw this pen. Our beam is we have a support. Sorry, I cannot draw a straight line. Okay, here, and then you have a roller here. And the load is here. X, right. Then distance is 4 for all 4. Here is 4. And then this is 4. Oh, and then 4. Okay. So that's our beam. Okay, so we take the first we take the worst points. Point C is here. Oops. This is point C. So on the left of point C, we resolve the shear. And we resolve the forces. So we have a shear downward. On the left is downward. And then moment C counterclockwise. And then we put the load 1 at X distance. And this length is 4 meters. So we resolve the AY. How did we get AY? We have to solve AY first. I didn't solve it with it. Take the moment. Reaction AY. Wait. 1/8. Hey, we didn't solve. Okay, we solved the first the reaction AY. We take moment at with respect to we take moment at P. So AY times 8. Negative AY, right? Negative AY times 8. And then minus plus 1 times what is it? 8, 8 minus X. Correct. 8 minus X. Yeah, correct. 8 minus X. So AY will be, AY will be equals, we put 8x 8 over 8 over 8. So 8 over 8 is 1 minus x over 8. Yeah, sorry. There. So we have resolved AY is at the same. I'll go back to 1 minus 1 minus 1 or x over 8. Okay. Then we resolve also. We also need B, right? We don't need BY. We only need AY. So it's our solution for then 1. So AY is 1 minus x over 8. Okay, so we have it. So that's why we have this AY here. Then we can add all the vertical members. Also, we add all the vertical forces. Okay, so summation of Fy equals to 0. Okay. Sorry, cannot find. Okay, summation Fy equal to 0. Okay, so what are the forces? We have AY upward. AY upward. I'll write it here below. AY is upward. And then downward is 1 minus 1 plus BC. So shear is negative also, minus BC. And substitute 1 minus 1 over x over 8 here. We will have BC, because this one equal to 0. Oops, sorry. Equal to 0. So BC will be BC negative, AY is positive, equals BC, AY will be 1 plus 1 minus 1 over x over 8. And then what else? Minus AY, minus 1. Minus 1. Oops. So minus 1. Yeah, don't equal. I delete 1. Erase. And then if we minus 1, it will be x negative, left only negative x over 8. So that is our answer here. So the BC on the left side of a point point C is a negative 1 over 8x. Okay, so so we can erase the other. Erase this first. Okay, so then resolve the forces on the right side of C, but we are still using this side. So we put the load on the arbitrary, it's just after, so it will just be right after point C. So if we resolve the forces, BC will be downward here, and then what we have AY, and so adding all the vertical forces, and summation Fy again, summation, sorry, Fy equal to 0. What are the forces? AY, upward, downward is BC minus BC. So BC is equal to 0, right? If you only have two for what do you call it, number, so BC will be equal to AY. BC is equal to AY, and AY is equal to 1 minus 1 over 8x. Okay, so then we can plot this equation. Okay, so probably okay, we can use this influence line equation for shear to draw our to draw this. How we come up with this is, okay, we substitute the values. Okay, so we go back to the table, we tabulate. Okay, example 2. Okay, we using these two influence line equation for shear at point C. These two. These two equations. Okay, this one will be on the left of C, and this one on the right. So we tabulate it. back to here. Okay, so if our x is at 0, BC will be 0 because 0 to 4. If you put it here, where is it? Okay, if you substitute 0 to -1/8 times x equal to 0, so BC will be 0. Okay, so we can plot it here 0. So if x is at on the left side, negative 4, or on the left side, that's why negative sign. On the left side, if you put in 4 here, it will be x. If x is equal to 4 over 8, it will 4 is equal. This equation is back for if your load is if x is greater than if you x greater than 4 and is 12, your equation will be this 1 minus 8, 1 minus 1 over 8x. Okay, so okay, so your point is at on the right of point C, which is 4. So we substitute 4 here. Okay, substitute 4 here, so it will be 1 minus 4 over 8. It will be 1/2. So it will be 0.5 positive. Okay, so if it's at 8 here, so 8 over 8 is 1 minus 1. So 1 minus 1 will be 0. If it's here, 12. Okay. Substitute 12 over 8. Okay. 12 over 8. 1 minus 12 over 8 will be 0.5. Okay. So that will be then we can, after we have tabulated this, then we can draw the influence line. This example. Example 3. Let's go to example 3. Construct the influence line for the bending moment at point C. So we have another the same as the example 1. Example 1. Okay, so example 1, we know already that AY is 1 minus 10 over 1 over 10 x. Same as example 1. Example 3. Okay, and then point C. But we want to take the moment at point C. Okay, let's resolve the 5 and 10. Okay, that's not. Let's draw. Our beam is like this. 10 meters. And the roller here. And then we'll take the maximum moment at C. Maybe this is a 5 and another 5. So the total length is 10. So we know from my example 1, right, that AY is 1 minus 110x. So we can use this value and then solve the moment at on the left and on the right of point C. Okay, so if we cut the sections on the left of point C, we will have a shear downward and moment at C counterclockwise, and then on the left is on the right is clockwise and then upward. So if we take the moment at C equals to 0. Where is it? Is this one? Okay. So for the length 0, if our x is greater than or equal to 0 but less than 5 meter, so our equation will be take summation moment at 0, moment C equals to 0, and then MC counterclockwise plus 1. Which one? Where did that one? It's here. Sorry. 1 times 5 minus x. So this is the distance. This one is this. Pointer. Okay, this one. So 5 minus x will be this x, and then the 5 is here. So 1, the force times the length minus our count AY. This is AY. Counterclockwise. AY is equal to 1 minus 1 over 10x times 5, because that is a distance equal to 0. Then we're solving for mx. MC is equal to 1 over 2x. So for x at if your x is greater than 0 and less than 5 meter, this will be the formula for MC. And then for MC on the right side, if it's if your x is greater than 5, less than 10, this will be a formula for the influence line of moment at C. MC minus AY. We still have AY here times 5. So because this x, our point, our load is here already. It's more than x is equal is greater than, so it's after the C, and then so it will be 5 minus 1 over 2x. Okay, then we tabulate again. Let's go back here. Okay, so on the left is this will be the value. And then on the right is this one. So if x is equal to 0, then MC will be 0. If x is equal to 2.5, so 2.5 over 2 will be 1.25, and the x is equal to 5.5. 5 over 2 is 5 minus 2.5, so it's 2.5. and 7.5 will be 7.5 over 2, 5 minus 3.75, and then if it's at, if this is 10 over 2 is 5 minus 5, it will be 0. So you can draw 5. Okay, this C supported beam, you know that the influence for any beam length, you know that the influence line will be like this. It will be like this. But the rate with is the 0 and you equals 0. You take the middle. Yeah, you take this. You have to take this so that you know the height of this. You don't need to have so many points because of so much of. Just take the half of the beam. If it's simply supported, like if your beam is like this, if only simply if the beam you're resolving is simply supported, and then you want to know the moment at C, but C is the midpoint, and then you can use you can just take the what do you call this the you can just take midpoint and then the last point. You don't need to take 2.5 and 7.5. So you just use 0. You can put but you know already, right, that this will be 0. Then you resolve for 5, and then we resolve for 10. Okay. Sample 4. Okay, for this one, it's more complicated. So we need to construct the influence line. Did I have any? Want to check. We construct the influence line for vertical reaction at support A. Where support A here? And then shear force at point B. And then what is RA? And then a bending moment at point C. So okay. Reaction at point A. This is A, point A, and then shear force at B, and bending moment at C. You have to tabulate. This one. Meron pa agad answer. Next page. Okay, here. We have to solve the Let's see. Use this. We have to put it in different locations. C is L over 2. Here for calculate the value. Sure, possibly. Let's see. Let's see, is equal to L over 2. Okay. So if you put let's tabulate the value for, okay. So to solve these beam problem, we first place the value or our load one at a certain location. Right here, because we have we don't know the length of the beam is L over 2, so we have to we cannot make another what do you call this another variable, so we don't use X. Instead, we put this loading at a known location so that we can resolve we would know where is um, the exact value. Okay. So first, we put the load at 0 here. We put the load here, and then we resolve the reaction at where's A? Reaction at A, and then moment at C, and shear at B. So when you have the load here, okay, then you will have okay. Okay, yeah. So we put it here. First, we put it here. So if you have a load here, then it will also be because you have a pin here. So see this here you have a roller pin, and then yeah, we have a pin here and then a fixed support. So if you have a load here, so if you cut the if your load is in at the end here, it will if you want to resolve the what do you call it, the load at the pin here, it will still be as you can transfer it here, and then if it's downward here, your load will be upward. So then you can now take the moment at C. Sorry, moment at C. Yeah, moment at C. This point C. And then for this one, you only have one force. This force upward. So your reaction will be RA will be -1. Okay, and then your shear will be this +1. So if you take the moment at C, it will be RA, which is -1 times L over 2. Let's see. Moment at C again. And so this. Mhm. Mhm. So your moment at C is here. Let's see. It will be -1 times L over 2. So it will be -L over 2. Okay? If your point load is at the support, so you move the load here, it will be, so there will be a reaction here. So there's no load on this area, and so MC will be equal to RA, and MC equals RA equals BB equal to, so it will be 0, all the forces. So because your load is here, if your load is in this directly at the support, so there'll be no your moment and reaction at A, and shear at B will be 0. Okay. Then if your load is at point C, okay, so this one. Is a point there. Okay, so your load is at point C. You take moment at moment here. Moment at this support, your load will be 0.5 here, and then upward 0.5. Okay. Good question. Yes, any question?
Hello po. Hello po.
You
Good
can
afternoon
unmute.
again. I would like to raise the concern po sana if it's okay for you to turn off your camera po para ay
Yes.
medyo choppy, nagiging choppy po kasi. So para ma-lessen po yung
Oh,
for the internet. Yes po. Baka po
ah,
baka po mas
yes.
maging mabilis yung internet if ever po. Thank you, Miss.
Oh,
Pag nag-return. Thank
okay,
you, Miss.
thanks. Okay. Thank you. Okay. Thanks. Okay. Okay, enough ko na. Sorry. So, hopefully, maayos na yung connection ko. Okay. So, we will never reach out. Okay. Where are we now? So, for n5 times, okay, so moment at C equals 0.5, our load is 0.5 here, load is 5, so I will is point negative. So, if your load is at move again, your load is here, then you take the moment at C, there's no load here, so it will be 0. And the RA will be, we only have one load, so RA is equal to, is downward, so RA will be +1. and BB will is the shear here is -1. So remove again your point at point B. Moment will be moment at C. You can see the load is in this side, so moment at C is 0. RA equals to +1. BB is -1. So we can now construct our here. Wait, I'll bring it there. Oh my God. Yes, yes. Oh my God, see them. Oh my God, see. Okay, try. So you can tabulate all those that we just now calculate is over here in this table. I didn't yeah, all this value we can put. Okay, wait, let's see. How do I put it there? Okay, so first we have 0 and the 0L and then L over 2. Oh, this is 2L, 2L here, 2L, and then I don't know. Here is a 0, then L, 0L, and then 2L, 2L here, and then oh, here is 2L, and then here is a 2.5L. Okay, let's see the table. Okay, and then 1.5L2. So just now the one that we resolved is tabulated here. Okay. So now we use the influence line equation. We put it at the X location and then solve for BE. And then solve for the equations for the moment. So we take moment at summation moment at D is equal to 0. So what are the forces? This force -1 times L plus L minus X. So this is X, L minus X plus the shear VE times L. Plus it's moment at D. So the distance is L2 plus L2, so equal to L. So the shear at VE is equal to 1 minus X over L. And moment at C for 0 to, if your X is greater than 0, less than 3L over 2. Moment at C, V will be the shear force. This shear force. Moment at C. Moment at C. Shear force times BL. And BE is equal to L. B is equal to 1 minus X over L. So if you substitute BE into this equation, you will have L over 2 plus X over 2. Okay, so for your X, if it's a greater than 3L over 2 and greater than 2L, your equation will be BE, it's on this side, BE, X, so over here. BE times L over 2 minus is 1 minus x minus 3L over 2. So where is 3L over 2? This is C. Because we have L here plus L over 2. So it will be 3L over 2 equals to L minus, if you substitute the value of B over to this equation and simplify it, you have L minus X over 2 for this, if your load is at 3L over 2 and less than 2L. Okay. And so for RA, RA will be, because you only have A here. This is BE, so we only have BE. So RA is equal to BE, which is 1 minus X over L. And shear at B, it's also equal to BE. Okay. For okay, so for 2L, if your X is at greater than 2L, but less than 3L, so it will be here. So moment at C is equal to, so your load is after C, so your 0. RA reaction at A will be 1, because you only have this point load, and then shear at PB is equal to 1 for X if it's greater than 5L over 2, and PB equals to 0 for X if it's less than 5L over 2. Okay. So application of the influence line. So once the influence line for the function, like such as a reaction, shear, or moment, has been constructed, so that's now what we have earlier done. We construct all the line for beams, simply supported beam, and then we also have that's beam with different with beam and able to position the value of the function. In this case, the reaction at point A can be found by multiplying the coordinate of the influence line at the position X by the magnitude F. So if you have F, if you have so if you know already your what do you call this have the influence line, you would know the value of AY, reaction at A, if we multiply the magnitude of F. Okay, so the maximum value of reaction at A, of course, if the load F is placed at the point A, at that point A. So meaning, if your moving load is at when it's here, you will, if your moving load is at A, you will have a maximum reaction at A, right? Because it's just yeah, it will just be your AY equals 1 times F. If you know this value of F, the force F, you multiply by then next. Okay, for uniform load, the value of the function due to df is equal to df times y equals to, so if, for example, you have uniform load, so uh, this uniform load this uniform load will be the value of the function due to the df is equal to, wait, df times y is equal to w. So the load wo times dx times y. So the value of the function due to wo along the beam is the integral of df y from 0 to the length. So is equal to w o dx. Dx is this small distance times y is equal also to wo integral of y dx from 0 to L. Okay? So the value of the function caused by uniform load is the area under the influence line for the function multiplied by the intensity of the uniform load. Okay, it's all for equation example 5. So determine the maximum positive live shear that can be developed at point C. So we have point C again. That can be point C due to the concentrated moving load of 4 kilonewton and a uniform moving load of 2 kilonewton. Have we resolved this? Let me check. Wait, I check first which if we have resolved this earlier. Over here. Okay, we didn't. Okay. This one. Okay. This example 5. So we have to draw the influence line for BC. Okay, determine the maximum positive live shear that can be developed at point C. Point C due to the concentrated moving load of 4 kilonewton and a uniform moving load of 2 kilonewton. So if we solve for the value of for the influence line for BC, okay, I think we have to solve it first. I'm not sure if I have it here. Okay, I don't have the calculation. Oh, wait, I'll find the calculation for that. See 2.5. Okay, let me share another screen. Stop share. It's here. To get that. Oh, I don't have. use I use the other method, Wheeler. Okay, let's teach first the Wheeler. This is easier. Oh, okay. Let's go first to Presto principle. I use Wheeler Presto principle to solve it. Okay. Okay. Okay, wait. Okay, I wait. Sorry. Miss. Yeah, correct. I know. I will have to teach you first the Miller. Yeah, to solve it, I need the Miller, uh, Muller-Breslow principle. Okay, just a while. Thanks for requesting. Okay, I share the screen. Yeah. Okay. Okay, so we go to this first before we. This one is easier. Okay, to solve we'll go back to question number 5. We'll use this Muller-Breslow principle, which will be much easier compared to the. So I have mentioned earlier, we got 3 method to do the influence line, the for um, the what do you call this, the reaction moment and shear for for the beams, for the determinate structures. So one is the one that we do first, we tabulate, and then what did you use, right? We use statics to calculate uh, and then put in at certain location the variable load, and then we tabulate it. And then next, after that, is the influence line equation. We can also use it. But then this is the third method to do it, is a Muller-Breslow principle. Okay. Then after we have discussed this, we'll go back to question number 5, because I resolve it using Muller-Breslow principle. Okay, so the influence line for the moment at C, step 1 is to uh, wait, this is not the first. Okay. First is the introduction. Okay. So the Muller-Breslow principle in 1886, Heinrich Muller-Breslow developed a technique for rapidly constructing the shape of an influence line. So the influence line for any reaction or internal phase, shear, or moment corresponds to the deflected shape of the structure to produce uh, by removing the capacity of the structure to carry that force, and then introducing into the modified release structure a unit deformation that corresponds to the restraint removed. So a unit deformation refers to a unit displacement for reaction, a unit displacement for shear, relative unit rotation per moment. Okay, so but so for the influence line for the vertical reaction at A, first is to define the positive direction of the reaction at A. So, the reaction at A, so define it, so define the direction, so it's RA upward, and then remove the vertical restraint supplied by the reaction at A. So remove the reaction and then displace point A vertically upward in the direction of RA. a unit displacement. Meanwhile, point B is not free to move in vertical direction, but is free to rotate. So A will, if you remove the vertical restraint, A will move by delta A, delta 1. So your unit force. So if you remember earlier, the simply supported beam, when we construct the influence line, we tabulate, right? It's this way, right? So it's just a one. The deflected shape is a triangle. Is an influence line at the reaction. So I go back, show you the earlier. Sorry, I need to go back to the first reaction, the one that we saw. Just to show you the there. You remember this? See the one that we tabulated. So if you use the Mueller, it will be just so fast, right? You just remove the reaction at A. Here. Remove the reaction at A and then deflect it by one. So that will be the beam configuration. We have it's in feet, 20 feet. We have a hinge here, roller at B, hinge at A, roller B, pin at C, and a roller at D. So define the positive direction of the reaction at B. So we define first there, upward, and then remove the vertical restraint supplied by the reaction at B. So when you remove it will move. So it will move delta equals to 1. Here is 1. Then you can, so if this is 1, and then you know your you have your beam length and all the distance, you can compute for this, right? So you have all this distance. So you just use a ratio and proportion. So if this is L, sorry, erase. If this, and then let's say this is a L over 2, L over 2. So you can cut solve for this one. It will be 1 over L, right? 1 over L equals to this X or Y. Let's say Y, that is your variable. And then add the L, it will be 3L over 2. 3L over 2. Then you can solve for Y. Because you know L, the beam, you know this, you have this value L. Okay, other 3 over 2. Then the dip is, it's here. Here, this one 3 over 2. So the deflected shape is the influence line for the reaction at B. Okay, so another sample for Miller-Bresson principle. So influence line for the shear at C. So remove the capacity of the cross-section to transmit the shear, but not actual force or moment. So where is C? Are we using a different one? Okay, so here we have a cantilever part, and then roller at B, and hinge at B, roller at D. And so we want to know, if we want to know the shear at point C. So remove it, offset the beam. So remove the capacity of the cross section to transmit shear, but not actual force or moment. So it's only shear. Offset the beam segments to the left and right of the section C by delta 1 and delta 2. So delta 1 plus delta 2 equals to 1. So it will be, so for segments AC and segment CD should remain parallel. Okay, so delta delta 1 is equal to 5 theta plus 5. That will be 15 theta. So delta 1 plus delta 2 20 theta equals to 1. So theta, it will be equal to 1 over 20. So delta 1, if you resolve it, 5 theta, so it will be 1 over 4, and delta 2 will be 3/4. So you will be 1 over 4, and then 3/4 here. Okay. So for this beam configuration, we got a hinge and a roller. And so if you want to know the influence line for the moment at C, step 1 is to remove the capacity of the cross section to transmit moment at C. So we will remove this capacity. So it will deflect this. The deflected shape will be this line will deflect this way. So if you remove the capacity of C, this point will is free to rotate, and then this point also. So apply a positive moment at C to the beam. So apply the positive moment MC to the beam at C. So we apply the positive moment. Okay, then the positive moment here. And then step 3, the deflected shape represent the shape of the influence line. So this deflected shape, because it will, the beam will rotate this way. But here, since we have a reaction, it will be in place, but it is free to rotate, but it cannot move. Like unlike point C, it will move. It will deflect this direction. A is it will rotate. Okay. Oops, that's it. So that's okay. So that is we have check shown you the example how to for the Muller-Breslow principle. Here we determine the what they call this the reaction at B, and then here for the shear, and then for the moment. Okay, so let's try one example. Stop share. Okay. Delta. Delta. Yeah, sure. This one. Okay, so I have here one example from the Hibbeler 7th edition. So draw the influence lines for vertical reaction at A, and then the shear at C, moment at C. So we have this is only A. This is this A. We have a polar at A, hinge at B, and then point C is here, 2 meters from A. And the total length is so the first I solved this using the method. So using the influence line equation. So if you put the what you call it, load at the x distance, yeah, cannot put already. Okay, if you put the load, you can see the hand of my mouse, right? So I just sorry, because I didn't not able to put it in the PowerPoint. So if you have a load is here, and then at a distance x, and then resolve for the what do you call it, the influence line for maximum ay. A will be 1 minus x over n, and then 2 over 8 will be 0.25 for the shear. This for the shear. Okay. Then let's resolve this same equation, same beam using the Euler-Breslau principle. So for the maximum reaction, what do you call, influence line for A. So we remove, the first step is to remove the reaction at A and then move it by a unit force. So this will be the influence line. For the shear, okay, for the shear, says to remove the, what do you call this? Wait, I check again. Here. Okay. Remove the vertical restraint. See. Remove the capacity of the cross section to transmit the shear, but not the axial force. So we have to remove the so we have to remove the capacity of the shear here, and then remove the capacity of the shear, and then place it. That's fine. Shear. Yeah. Okay, delta. Okay, remove the capacity of the shear and then move the, and then offset the beam segments to the left and to the right of the section C by delta 1 and delta 2. I'll share this again. Stop share. Okay, let's go back. Share. Okay, this one. Okay. For the shear, oops, okay. The step to find the shear at point C, remove the capacity of the cross section to transmit the shear, but not the actual force. So we will remove the capacity of the shear here, and then move it down, and then on the left is down, on the right is up, and then offset the beam segments to the left and to the right segment C by delta 1 and delta 2. So, and then delta 1 plus delta 2 equals to 1. So this one is equal to 1. And then segments AC and CD should remain parallel. So we use these principle steps to go back to this share screen. So the here put that delta is 6 is the distance here, because we have our beam length is the total length is 8 from T is 2 meters from A and 6 meters from B. So the one on the right delta 1 plus delta 2 is equal to 8, because 2 theta plus 6 theta is equal to 1, because this height is 1. Okay, so to get theta is equal to 1 over 8. And then delta 1 is equal to 2 over 8, and is 0.25. And delta 2 is equal to 6 over 8, 0.75. Okay. So another one. Okay. So let's go back to question example 5. Example 5. She's here. Where is example 5? Ah, there. Okay. Oops. Example 5. It's the same. Okay. Example 5. Okay. Example 5. Okay, so it's a application. If you have you already have the intensity, the loading, the intensity of load, moving load, the concentrated moving load, and the uniform load for this example 5. So we have a simply supported beam, hinge at A, roller at B, and our point of concern is at point C, which is 2.5 from support A. So determine the maximum positive live shear that can be developed at point C due to a concentrated moving load of 4 kilonewton and a uniform moving load of 2 kilonewton. So earlier, when I discussed uh, the beam, simply supported beam, right? We know that the influence line for BC at what do you call this? At point C is 0.5 and 0.25, right? As previously. Even though, yeah, if you have a unit load 1, right? So it will be, even though the beam length here is different, so is we can still use this shear influence line of the simply supported beam earlier discussed. So is 0.25 and 0.75. This will be the what do you call the shear influence line for shear at point C. So for the concentrated load, the maximum when 4 kilonewton load is located at X is equal to 2.5 M. So VC will be 4. Okay. Wala ba akong internet? Sorry guys, I think I got disconnected. Okay, can you hear me? Okay, thanks. Thanks, Nicolo. Okay, so I'll continue. Share screen again. I'm still sharing, right? Can still see my screen. This one, right? Well, I stop share. Yes daw. Sorry. Hindi ko nakita. Okay. I'll share again. Oops. See this one. Correct. This one. Oh, okay. But I think I share again the other. Wait. Stop share. I'll go back to this so that I can. Yes. This one. Okay. Yeah. So we will use this influence line or influence line for here. This one. This influence line. So we don't need. But actually, we can calculate again. But it's already 3 p.m. Quite long to redo again. So we can just use this influence line and then apply it into the this question. Okay. So the influence line for shear is we're using this. So we just apply the maximum positive shear at C will occur when the 4 kilonewton is 5. So BC is equal to 0.75, this one, times 4 equals to 3 kilonewton. And for the uniform load, the maximum positive shear will occur when the 2 kilonewton load is placed between X is equal to 2.5 and X is equal to 10 meters. So for BC, the shear C, what is this? This is the this area of 10 minus 2.5 of 7 point. This one, right? And then times 2. Okay. This area 2 is this area. Okay, so the maximum BC is equal to the area of this because it's a uniform load. So this length is 10 minus 2.5 times height 0.75 and it's a triangle, so divided by 2 times the intensity of the load 2, so it will be equal to 5.625. So the combined load will be BC is equal to 3 plus 5.625. So total is 8.625. So that's the moment. Combine those. BC. We will take the moment. Share lang. Okay, so that's it. Have any question? I have no more example. Okay, and then for your further reading, you can refer to Hibler Structural Analysis 11th edition. Stop share. Okay, so yeah. Any question? So guys, check nyo naman yung answer nyo because you have 3 ways to do the calculation, right? So one is the using, just now we calculate using statics. Where is it? Share again. Just run through again the example earlier. Is it this one? Okay, go back here. Example. I know, should be here. Here. Share this. Okay, this one. Here. Here I have used two method ng equation for influence line at this what they call this diagram, and then Müller-Breslau principle. Just now what we have discussed. And then stop share. Right. Here. Share this example 2. Example 1. Example 1. Okay. Okay. Example 1. Here, okay. So for example, this same beam. So if you can tabulate it, but yeah, it is quite tedious, right? If you use all the you have too many variable, you put 3, you put the load at 2.55, and so to be able to construct the influence line for the reaction at A, you only need to put the load at 0, and then you draw the influence line. And then if you use the Breslau principle, it's actually you don't need to calculate. You just you just remove the reaction, then raise it up by 1, then you already draw this. Then for the influence line equation, you just put your load at distance x, and then take the moment at b. So if you want to, you can practice. You do this example. Draw the influence line at b. You use the Müller principle. Let's draw. So if you use the Müller principle, tells you to remove the reaction, right? Establish the direction of the reaction at B, and then I'm sorry, yeah, we will take the influence line at B. So it will be like this, and then B will be free to rotate, right? Then fix at A. I'm sorry, it wouldn't draw. Oh yeah, eraser, erase. Okay, so we need to rotate, and then this height is 1. Okay. So that is the influence line for IL4 at B of BY reaction at B. Oops, where is the IL at BY? Then actually oh, if you want to do the ah, what do you call this other line then what are the forces um x times 1 downwards negative plus by x times 1 times x times 1 plus by times 10. Where y I cannot again by times 10, so equals to 0, and so by is equal to x over 10. So this will be the equation for influence line at B. And then you can do the same for the shear and then the moment. And then practice. You can practice on any of these. I can give you these PowerPoint this slide. I can give it to the organizer, then send it to you. Then you can practice on, because those that we solve right is at point C. So you can choose other points and then please. So I'll stop sharing. Okay, that's it. Thank you guys for listening. I hope you understand the principle.
And thank you so much, Miss. Ayan. If may question pa kayo, guys, you can chat it to our chat box and para ma-entertain ni Miss. And if ever naman may want kayong i-clear pa or magpa-help, don't hesitate na i-ask si Miss sa Teams, or you can go to her personally. So, ayan. Of course, on behalf of ACES FEUA and the CE department, we'd like to express our heartfelt appreciations to you, Miss Aquino, or Engineer Aquino, for sharing your valuable knowledge and time. So, allow us to give the certificate of appreciation that has been recognized and honored by the Associations of Civil Engineering Students, FEU Alamang, for his invaluable contribution as a guest speaker during this event that took place on November 18, 2025 at FEU Alabang. In appreciations of your inspiring and enlightening presentation, ACES is truly grateful for the time and effort and expertise that was generously shared and left a meaningful and lasting impressions on the participants. And of course, kudos to everyone who actively participated this afternoon. So let's give our mentor a big round of applause. Ayan. So, Miss, ang certificate po and token of appreciations will be sent po tomorrow or later on. And then, ayan po, punta na lang po kami tomorrow sa inyo to give the appreciations or the token po. And then, ayan, if possible po, we would like to ask din po siguro yung sa PPT so we can give them to the students po.
Sure. Okay,
Ayan.
I'll send it, email to you later on.
Yes,
Tsaka
thank
yung,
Thank you so much po, Miss. Ayan. So, ito po yung certificate which will be sent to your email po later on. So, once again, thank you so much po, Miss. So, grabe. Buo morning hanggang afternoon session po. Thank you so much po.
Okay. Thanks, guys, thanks, ACES, for organizing this tutorial session. I hope I'm able to help you prepare for your final exam. All the best. And so all you need to do is practice. So if you have any question, you can visit me sa faculty kasi wala pa naman akong load. So I'll be there.
Yeah.
So just look for me.
Ayan.
Yeah. So
I would like to request po sana for photo opportunity again with the ACES po and to our audience, our students po, third year students of this specific. Yan guys, photo opportunity with Miss. So huwag kayo mahiya guys, sumapit kay Miss kasi napaka-approachable ni. Laging nakasmile. Ayan. Miss, picture po.
okay.
Ay, Miss, sana hindi ka po nahirapan sa amin. Kahit kaunti. Yung internet po lang po talaga, pero okay lang naman po kasi clear naman po sa students lahat.
Okay. Yung internet ko, sorry guys, dapat today maayos siya. Kaso nga lang hindi na-approve yung permit. So, hopefully soon maayos na yung internet connection ko. Right.
Yes po, soon. Para next review session ulit.
Yeah. Meron pa ba? Sure. No worries. Just message me pagka meron kayong kailangan sa reviews.
Okay, thank you so much, Miss. Grabe, big help po, especially to our third year student, helping them na mag-review for the upcoming exam po. Pero ayan, everyone, I would like to request again na mag-open cam po tayo para we can take picture with Miss. Yes. Kuya James, Kuya Lo, Kuya Anton, at Bridget. Huwag na kayong ma-shy, guys. Si Miss Lo.
Tayo lang. Nasaan ba? Ano ba to? Third year students?
Actually, Miss, halo-halo, Miss.
Halo-halo.
Okay. I'm sure naman po na yung ibang third year students natin is nasa live or if ever na hindi po nila mapanood to on time or I mean ngayon, isa-send naman po yung recorded vid ng review session po natin. So, that's the good thing.
Okay. Thank you guys for staying.
Dapat kami mag-thank you, Miss. Grabe. Ilang hours ka po.
Naintindihan niyo ba yung lecture ko?
Yes, miss. Nakapag-advance na po ako eh. From
Ah,
second year to third year na po agad. Sana ma-manifest din. Baka talon na agad. Ayan, guys. Ayan. O, di ba pwede na? Yan, picture na po tayo. Kuya Kurt, ikaw po mag-picture. Or Ate Asha. Ate Asha, pwede. Pa-request.
Si Crystal po yung magpipicture.
Ay, sige. Sabi ko nga po. Ayan. Miss, parang naka-off po yung camera mo po.
ano ba? Baka ano lang.
Sa
Medyo
internet.
nag-ano lang. Internet connection ko pa rin yan. Nawawala-wala. Okay.
No worries.
Yan. Meron na? Siya. Wala pa rin? Ako, ano yung camera ka? Wala pa rin?
Sa inyo guys, nandiyan na si Miss po.
Off ko muna.
Sige.
Yan.
Ayan, Miss. Okay na. Diba? Napaka-pretty na.
Okay.
Yan, Miss. Sorry, Miss. Pinag-off cam ka namin kanina. Ikaw pa naman ang pinakamaganda. Pumungad sa reviews.
It's okay. Kasi nga yung connection kaya nababawasan yung bandwidth. Yeah.
Nga po, Miss.
Mas importante yung audio. Hindi ko.
Yes. Loud
Yes.
and clear naman. Kahit naman, Miss, audio lang, ramdam namin yung kagandahan mo.
Wow. Diba? Tayo lang naman nandito, no? Okay, thank you. Thank you sa inyo pag-stay.
Thank you din, Miss. Okay. Time for a picture, guys. Nasaan na si Chris? Ayan, game na. Game na kami.
Okay, game na.
1, 2, 3. Aces po.
Isis pa. Ano
1,
ba?
1, 2, 3. Okay na po. Thank you.
Thank you,
Ayan.
guys.
Thank you
See
so
you sa
much
next
for
sessions.
Yes po. Next session po. Next sem. Pero ayun, thank you so much
Okay,
again,
thanks.
Miss. Napakaraming thank you po kasi hindi namin magagawa or matatapos yung review sessions without your help po. So, a big round of applause for Miss for one last time. Ay, virtual na lang. Ayan.
Yeah, next
So,
time, face-to-face. Mas maganda siguro face-to-face.
sige, Miss, dahil yung request mo, gagawin natin ng paraan yan.
Sige, thank you. Thank you, guys.
Thank you, Miss. So, everyone, I would like to extend also our thank you and gratitude for joining to our review sessions. So, despite na marami kayong ginagawa, still you made it and work. And also, we would like to say good luck po to our upcoming finals and hoping to lahat tayo maging pasado, hindi lang pasado, magkaroon ng mga matataas na scores. So, ayan, thank you so much everyone. So, before pala kayo mag-leave, baka you can take some time to, to answer our evaluation form, ayan, to help us to create a better event in the future, and yes. So, ayan, once again, good afternoon and thank you so much everyone. I'm Mariel Ricaro, now signing off. Bye, everyone. Oh, signing off. Bye po. Thank you.